In this demonstration, you will learn how to plot a sine function that contains an amplitude and a phase shift. This is question 2 of 3. The first thing that you have to do is analyze or look for your A, B, and C value. Your A value, which is always the coefficient or the number in front of sine, in this case there isn't one, but there is, it's a 1, it's just not written, is your A value. This will represent your amplitude. This number right here that is connected to the variable x represents your B. And this number right here will help us find the phase shift that will be represented as our C value. Now, given that you have a pi here, you can assume that this equation is configured in radians and not in degrees. And the reason why I'm pointing that out is because it will help us determine which of the two period formulas we will use. So let's write out everything we know. We know that the amplitude, and these two lines here represent the absolute. The amplitude is 1, and you always take the absolute of A. Your B value is 4, and your C value is pi over 6. Now with our B value, we can find our period, a very important feature when it comes to graphing. We will use this formula right here. Period is equal to 2 pi over B. And the reason why we're using this formula over 36 or 360 over B is because this equation is configured in radians. So I'll substitute this number into here, and I end up with 2 pi over 4 is equal to pi over 2. 2 over 4 is half, and that's represented right here, 1 over 2, and the pi on the top. The next thing you will have to do is you'll take your period and you will plot it some point away from the origin being right here. So let's refer to this point right here in this x and y plot as your period, and that will represent pi over 2. That is your period. Now to find out what these points are, you will need to divide this number, or whatever period you ever get when it comes to graphing these, by 4. And if you divide this by 4, you end up with pi over 8. And what this will represent is it will represent this point right here, pi over 8. To find this next point, you do pi over 8 plus pi over 8. To get this point, you do pi over 8 plus pi over 8 plus pi over 8. Now, of course, we don't want to show it unsimplified. So pi over 8 plus pi over 8 is equal to 2 pi over 8. So let's replace that with 2 pi over 8. And these added up equal to 3 pi over 8. Now, of course, you can reduce this if you like. You can make that into pi over 4, but there's really no need for that. You can just leave it as that. So, the next step is to find our phase shift. And our phase shift is defined by this formula. So our phase shift being negative c over b, that is equal to, c is equal to that value. And that negative comes from the formula. And our b value is 4. So our phase shift is equal to negative pi over 24. Now, if you don't know how to do that, you can use your calculator for this one. Negative pi over 6 divided by 4 is equal to negative pi over 24. That will help us determine how to shift our graph once we've graphed it. Now, since this is a sine function, we know how sine functions behave. They start at 0 and then they oscillate between. So if this is 0 and 0 and we call this point right here 1 and this point right here negative 1, a sine function without a phase shift would look like this. Start at 0 and 0, move its way to 1, then go back down, oscillate between 1 and -1, so down here and up here again. So what I'll do is I'll connect these points. And that is our sine function without the phase shift. Now, given that the phase shift is negative, this curve will be shifted to the left. So negative suggests left, positive suggests right. Every one of these points, these major points, will be shifted pi over 24 to the left. So this point will be shifted to the left, pi over 24, which would be some point. Let's find out how much pi over 24 is. Pi over 24 is equal to roughly 0.13. Okay? So, how much is this one equal to? Pi over 8 is roughly equal to 39. So, this right here would be negative pi over 8. And 0.13, which we found was equal to pi over 24, would be somewhere here. Now, since this is a sketch, we don't really have to worry so much about accuracy. We can assume that the point is right there, the new point. So this right here shifted this way. And we're going to use the same distance for each of the points for consistency's sake. So I'm going to move this over here. I just want to be consistent with this all the time. And this point will move somewhere here. This point will move somewhere here. And this point will move somewhere here. Now we're moving to the left because that number is negative. So I'll connect these together. With a solid line this time to signify my final wave. I'll try my best to connect this one here and this one right here. Now your teacher might want you to give these exact points, and that's not really hard to do. To find out what this point is, you would subtract pi over 2 from pi over 24. You would subtract this number right here from pi over 24. This number right here, 2 pi over 8 with pi over 24. And you do the same thing for the rest of the points. So there you have it. This is how to graph a sine function that contains an amplitude and a phase shift, but is configured in radians.